federal. Sorry, I missed the recording. Let me introduce you all to David O'Brien. He is co-founder and president of SurvTech Solutions, Inc. and has over 27 years of experience in the surveying profession. He's a professional surveyor and mapper licensed in 10 states and a certified federal surveyor.
Okay, can you hear me now?
Yes, I can.
Are you seeing my presentation?
Yes, we can see your slides.
All right, good. All right, so I'll go ahead and get started. Thanks for the introduction and thank you for allowing me to present today. I really, truly appreciate it. We're going to speak on unmanned aerial systems today. So let's go ahead and jump right into it. First off, I do own the company that has all these drones. I am a professional surveyor, but there's a lot of people that help me with this. I have a UAV department manager, Mike Bickle, that's very involved in this. All the aerial imagery we collect is overseen by Carlos Prieto. And then we have a certified photogrammetrist, Ken Como, that's in charge of LiDAR, and his actual son does most of the LiDAR processing. So let's go ahead. And you already heard an introduction about myself. I'm a professional surveyor licensed in 10 states, hopefully 11. I just took an Arkansas exam. We'll see how that goes. I'm also a certified federal surveyor, which kind of makes me an expert with Native American owned lands and the public land survey system. I'm also a lead AP, which is kind of interesting. And I have a Bachelor of Science from the University of Maine in 1993, and I've owned a business for a long time. So I was a previous owner of a business before SurvTech. So let's jump into some definitions because it can get really confusing out there. And so I like to start with these. A UAV is an unmanned aerial vehicle. It's just the drone, nothing else on it. It becomes a UAS, an unmanned aerial system, once you put a camera or a sensor or some kind of device on it where it's doing something besides just being a UAV. UASs is just a small system like we run. Anything under 55 pounds is really a small UAV. An IMU measures inertia, heave, pitch, and roll, which allows us to do some really high accuracy stuff when we're taking LiDAR, collecting LiDAR data. Obviously, you all know what GPS is. Post-process kinematic is another form of GPS. Instead of doing it real time, you post-process it after the fact to get survey grade accuracy positioning. Real-time kinematic, I really just explained that. You're getting real-time position to survey accuracy. And then VTOL, vertical takeoff and landing. Those are some of the latest UAVs. Instead of trying to throw them or launch them, they actually take off vertically and land vertically, and they're a fixed wing drone. Types of remote sensing data we're going to talk about today. We'll do imagery for inspection. So this is not really mapping, it's just collecting imagery to look at something and inspect it. Rectified ortho imagery to make ortho mosaics. Obviously an image that has scale and distance on it, so it's really a map. Collecting video. And really, I claim to fame LiDAR, light detection and ranging, and then infrared and multispectral, and even a little bit of magnetometer work can be collected from a drone if you're looking for unexploded ordnances or metal objects. I always like to talk about the pros of UAV use. Obviously, you can reduce costs. You can collect a huge amount of data over a ground survey really quickly, so it's more efficient. You get a nice perspective. A lot of people say, well, why don't you just do mobile LiDAR or mobile imagery collection? Well, the overhead and oblique imagery collection and LiDAR collection is obviously better. You're looking straight down on utilities and power poles and other stuff. Data density, the amount of detail you get, which all adds up to efficiency. And then safety. We do a lot of sites where you're really keeping people out of harm's way. There are some cons of UAV use, and I always like to discuss that. You have to maintain line of sight unless you have a special waiver. So you can't fly your drone 3 miles away and land it in the Bucs Stadium and take pictures. That's not allowed. It's not allowed to go with the stadium anyway. Battery capacity. Even one of our bigger drones is a DJI 600 Plus. You really only have 18-minute flight time. Restricted areas near airports and military bases. There's a lot of restricted areas in Florida, and if you follow the rules, there's a lot of areas you can't fly. Vegetation can eliminate any type of imagery usefulness for ground surface. and then extensive data processing, expensive software, large data sets and storage requirements. And then, obviously high liability. We run 10 million in liability on our drones, so it's very expensive insurance. It's not cheap. So obviously there are some challenges with doing UAV work as well. So let's jump into the first one. This is our latest UAV. So this is a vertical takeoff. It's a Wingtra. It has built-in PPK positioning for very accurate surveying. We do not fly LiDAR with this. This is all imagery. So we can collect RGB overhead imagery for making ortho imagery, oblique imagery, multispectral, and some really nice data density too. I mean, we get 1.5 centimeter GSD at 120 meters, which is really nice. And this thing only flies for 60 minutes. And when I say only, there are fixed wing UAVs that fly for hours. We like this one because of the camera packages. We have 3 cameras that can be in this UAV at any one time. And we like the vertical takeoff. You can launch the fixed wing. It takes a lot of energy to vertical takeoff and vertical land, hence it cuts the flying time. But the advantage of a fixed wing, it just flies so much quicker. It can cover so much more real estate, ahead of time. So compared to a rotor, to helicopter drone. So this is a video. I hope it plays for you. This is it taking off. And it goes pretty quick when it takes off. They talk for a few minutes, but just go ahead and look at it. So that's in its vertical takeoff position. And so it's going to go ahead and pretty quickly, you'll see the rotors on top of it spin up. And what it does, it goes vertical in this position and then just flattens out into a horizontal flight plane. It flies like a plane at that point. So, but it does take a lot of energy when it lifts off. And I think it's about to do that any second now. So you see how fast that got up in the air and took off. That's a huge benefit compared to, we had one that we used to throw to take off, and it always crashed. We had to throw it and land it. So this vertical takeoff is really nice. And it comes back and lands the same way. I don't have a video of it landed. I need to get one, but it's the same. It just backs itself down, lands in the same place. So with that type of fixed wing UAV, we're going to collect a lot of imagery. This is actually with our old fixed wing. It wasn't a vertical takeoff, but you can see the level of ortho imagery you can collect from this. This did not have a great camera on it. Like our newest one has a 48 megapixel. This one only had, I want to say, right around a 20 megapixel, but you can still see the level of detail. We were doing an Alta survey on this site. It was in Georgia. We had 13 minutes of flying time and probably 6 hours of mob time each way. You can actually see the target there. You can see the pool. You can see the planimetric features, the parking spaces, all readily mapped. We still had to put boots on the ground for the boundary survey and for doing utilities and mapping the building, shooting the building corners, not using the roof line, but it saved us a lot of time. Another example of ortho imagery. I like to show this one because this was collected with just our simple Phantom 4, which is a DJI product, 20 megabyte pixel. You can kind of see the level of detail here. You can see our landing pad, the H, the red circle, that's where it takes off and lands. And I think in the next slide, we actually zoom in. You can actually see it's pretty high quality data, a lot better than you're seeing from certain aerial flights, countywide and so forth that you may download on Labin. So pretty high quality from only a 20 megapixel camera. And it's flying at 400 feet, which is the upper ceiling. We could fly lower and slower to do better imagery, but this was actually flown at the upper ceiling of the UAV zone. Oblique imagery. This is actually a sand mine. Done a lot of oblique imagery over the years. We hope to do more with the latest drone we just added. You can obviously see this is a sand mine with piles of inventory sitting there and so forth. Then when we turn around and we can actually map those piles using imagery. To be perfectly disclose the truth, we don't do this much anymore, but I want to let everybody know this is available because you can buy a very inexpensive drone with a very inexpensive camera and use a couple different programs like Pix4D or SimActive and map these piles, do digital elevation models, make a DTM, contouring, create volumes. We stopped doing it because we had errors that would show up now and then, and we're surveyors, and so we don't want to tell our client we have to go back to the site because our data's bad. That's we stick with LiDAR more, but I do like to show people if you have an open site with no vegetation, you can do some really cool survey and photogrammetric mapping with just really inexpensive drone and camera. And so I mean, that's something to keep in mind if you're doing it. Just be prepared if you see a hole in the middle of the site that's 10 feet deep, it may not be there. A lot of companies have gone to where they do this on their own, and then they upload the data to a black box type situation to the cloud, and somebody else processes it and gives them values. I would actually challenge people to look at their data. We've had a situation where we were told our volumes were wrong, and when we looked at the data they sent to the black box, nobody stripped out the conveyor belt that was above the pile, which added volume to the pile, and nobody checked it because it was just a black box type scenario for processing. So, I mean, I think at the end of the day, if these numbers or volumes are going somewhere critical, you better putting eyes on your data and looking at it. So I'll just give you another, this is a mine site, again, done with imagery. You can see all the images that were collected in the lower right. We created an ortho image, and then we created a point cloud for the topography, made a digital elevation model, created a digital terrain model contour, and did volume calculations. This was probably, a few years back, because like I said, we don't do as much of this anymore. But again, it's still out there and you can still do it. One of the later DJIs, this is 4th generation. They've kind of souped up their drones a little bit. This is a 300 plus with an RGB and a thermal camera built in side by side. So basically we use this a lot for inspection or looking for things that give off heat. So this has built-in LiDAR, not for mapping, but for avoiding objects. So it won't run into a bridge, it won't run into a power pole and so forth. It has a laser rangefinder, which it knows how far above the ground it is, which is also advantageous. You know your flying height. And then it has the 20 megapixel RGB and infrared camera that you see simultaneously side by side. It also has upper and lower gimbals and horizontal and vertical gimbal movement. So really, you can put that UAV anywhere, and you can move that camera really in any position. So it gives you a lot of flexibility to look 360 degrees up or down horizontally. And then it has a forward-facing camera, so you can have a heads-up display and be seeing when your UAV is flying in all time, real time. So even though you still have to see your UAV in line of sight, you still have the ability to see what the UAV is about to run into or avoid or so forth. So we do a lot of inspection-like work on the ecological side. This is actually some bird nests we've done over the years. They're looking to see if there's, baby birds in it, if there's eggs and so forth. And obviously on the left, that's just an empty nest. On the right, there's a bird in it. And we've done a bunch of these. I mean, I guess ecologists have to sit on site for a week or two, looking at a nest. But if we go up and inspect it with a UAV, that ends it right there. They don't have to put a person up watching that nest for days. So this is actually a video of that, and I'll probably cut it short because it's a long one. I will say that every bird reacts differently. This bird sits here, you're going to see, and you're going to see there's eggs in the nest, but other birds have flown off, and then some birds have actually attacked the drone. Now this is a cell tower. This one does not attack, so it just sits there calmly. So with that, I was just trying to point out that we try to be as least intrusive to the bird as we can be. We stay up quite a ways away from that, but you can really get a good look at what's in the nest. Some other inspections, which is used heavily, is utilities. I mean, you can kind of see the level of detail on this screen, connections that are disconnected, bolts that aren't cranked down right, things that might be cables that might be failing. And you can never see that from the ground. You can see that, really well, from the air, and get really close up. And this is not even a high-end drone. You can go with much higher cameras and so forth. Bridge inspection, same thing. I will say that bridges can be challenging. Bridges create wind. And so you have a drone that's trying to avoid objects, that's pushing you away from an object. You're trying to get in to take pictures, close-up video, imagery. It can be challenging we have a great pilot. He's flown for the military, he's flown for Lockheed Martin, and bridges can still be challenging. I mean, you have to be careful. but you can kind of see the level of detail there. You can look for cracking, drainage features, and so forth. This is the infrared from the 300, and you can colorize the infrared any way you want. You can do black and white, you can do different colors, and you're seeing this heads-up display in the field. You can obviously see the roadways hotter than the rest of the terrain, and that color scheme can be visualized any way you want. When you get back to the office, you can switch that to black and white or different colors. So I'm partially colorblind, so to me it really doesn't make a difference, but to somebody that's studying this data, they can colorize it any way they want after the fact. Just some more, you see the, obviously the cows on the right, you can see them in the infrared image, and so forth. And it just, you can use this for search and rescue. You can use it to look for wells that are hidden by vegetation, because a steel casing well will heat up and cool down differently than the terrain around it. And this is another black and white. You can see the cows out in the woods. I mean, they show up pretty well as black features. And we've actually done it looking for temperature loss on veterans hospitals. This is actually a VA hospital. I'll give you a little bit of this video showing the drone flying. I mean, it's pretty, you'll see why copters are so advantageous for UASs. I mean, they just hover really nice. They sit there, they can be moved around really nice. It's very, very stable platform. And there was a lot of logistics that went into this. We couldn't have any patients in the windows. They didn't want any patients captured. So obviously this is kind of what the heat map looks like for the window loss. One thing I always have to mention is we're just surveyors. So we do not do anything with the data. We collect and we usually provide it to an end user or an engineer or somebody that's looking at it in between. So you can obviously see the different heat loss at the windows. And this was to actually replace these windows. They wanted to see which ones were failing, so which ones weren't. All right, so this was a test we did in-house, and nobody's ever actually hired us for this. This was an infrared camera on the Gulf of Mexico looking for seagrass, and us and an ecological company did it together. We were amazed at how seagrass really showed up. You did have to have water clarity, which but Tampa Bay is not the clearest water in Florida, so that gives me hope. I was just amazed that the vegetation really popped for this, and the ecological firm was impressed as well, but we've never used it to map anything, full disclosure. I mean, we just did it for our own in-house purposes. This is what a magnetometer looks like. And so, I mean, we've done work where you're flying, looking for unexploded ordnances. You're flying about, keeping that magnetometer about 30 feet off the ground. And so this was actually over the coast and over a beach. But it's a pretty unique application of a UAV. Kind of our claim to fame, we run two LiDAR UAVs. One's a DJI 600 with basically a LiDAR USA HDL 32, which is a Velodyne package. And then we run a Harris H6 hybrid. The Harris H6 is a gas electric drone, and it has a 2-stroke generator that actually powers batteries as you fly, so it can stay up about 90 minutes as compared to 18 minutes with the DJI, and it carries a much heavier payload. You can't really tell here, but it's a much bigger drone than the DJI. It's a big drone. If you want to know what it sounds like, if you have a trimmer or a weed whacker, it basically sounds like a flying weed whacker. So it is challenging sometimes. People notice it very quickly compared to another drone. But it'll stay up for 90 minutes and collect a lot of LiDAR. We can do 300 or 400 acres of LiDAR probably in 90 minutes. So I like to talk about what's on the UAS when it comes to LiDAR, because there's a lot to it. You're going to have a LiDAR sensor, which this one is the HDL 32 made by Velodyne, but you're going to have an IMU in it, which is going to measure your inertia, your heave, pitch, roll, acceleration, and so forth. And so that helps position the sensor head along with the GPS. And then this one flies also a camera simultaneously. Now, you can't really map imagery and LiDAR simultaneously, so we typically do 2 different flight plans. There are drones out there that do it. They're very expensive. We like to customize our drones with the sensor we like. So the ones that do it simultaneously are all built in together, and you can't really change sensors. So it's not advantageous for us. If you look at the LiDAR data, you can kind of see the level of detail. This is our older system, but even with the older HDL32 system, which we've been flying for about 4 years now, you can see the amount of data you get. You can see the lane lines. You can see the intensity coming off those. So it's pretty easy to see that you can map those features, and you get some really great topography. We've got our LiDAR, both units dialed into under 1/10 of a foot accuracy. So we like to tell people that we're right there with RTK grade GPS. Whether I put boots on the ground with GPS or I do it with the drone, it's the same accuracy. You can see the error ellipses there that we were 300ths, 3000ths, 0, and 200ths basically on when we did our check shots and our calibration. And we always do checks. We always do ground checks to make sure our LiDAR is on the ground. And this is kind of an end product. You see us after we've done a DTM of the site. So the great thing about LiDAR is the end user doesn't have to know it's LiDAR. It can be, once we push it through a DTM and contour it, it really doesn't matter to the end user. If they want to see the LiDAR data, they can see it, but it really, the final product is the same. I always like to talk about this. This is a very heavily vegetated site with some water in it. LiDAR does not like water. Now, I know everybody's heard about bathymetric LiDAR, but bathymetric LiDAR is very expensive. They do have some smaller units on drones, on UAVs, but in our opinion, they've not been worth the investment yet because they're more like a profiler than swap data, point cloud. And they have bathymetric LiDAR in planes, but it's like a $4 million investment. So it's not something you're putting on a drone right now. But if you look at this site, it's heavily vegetated. And then my guys did the filtering of the vegetation, and you look down the lower right, it still has a ton of data. Even in the treed area where you remove trees, you see those little black spots. Trees are gone, but there's still elevation data in those spots. I mean, you may have trouble seeing it on the screen, but it's still there. So even after we filter out vegetation, we have a lot of topographic data. And so I always ask my guys as a surveyor, how do they know that the natural ground is good? Well, this next slide kind of shows it. We're getting upwards of 150 points per square meter on our LiDAR. And people are like, man, that's a lot of data. And they said, why do you need so much? Well, when you filter the vegetation off, you may only be left with a percentage of that. But if you get 150 to 200 points, you may have 40 or 50 points per square meter still left. So you look at the thickness of the natural ground. If the thickness is like 1/10 of a foot, my guys feel very comfortable the ground is good. If it's 4 or 5/10, then they'll say, yeah, this area is suspect. It really handles vegetation well, with the exception of palmetto bushes and Kogan grass, because Kogan grass is so thick at the bottom. And so it's something to keep in mind. We do a lot of utility work with LiDAR, map utility lines all across the United States, really. But with the drone, we can fly 400 feet with our Regal system right at the upper limit and get data density to really pick up the line and the facilities well, the overhead, all the connections and all that. So it's extremely efficient with our newer Regal Buck system that flies on the hybrid, which is an American-made drone as well, so that has benefits. And then you can colorize the point cloud, so you're looking at trees and everything been colorized by imagery that we've taken. So you can really turn out a nice product. The electrical companies, the power companies can see what their sag is. We set up a weather station, and we can calculate the sag at a certain temperature, and so it's really helpful to them. This is actually probably our most famous site. We actually flew the Oroville Dam when it burst out in California. We were flown out there in one day. We flew it the next day and turned over the data the same day. So it was a very difficult flight for a couple of reasons, but the dam is very steep. So we had to fly it manually to stay the same distance above the spillway. And then we had to cross under some transmission lines. So it was very challenging, but we were able to map it and give them the data, and they were very happy with it. Same thing, bird sanctuary out in Washington State. Couldn't put boots on the ground, but they had to do some work on it in the summertime. So during the spring, they wanted to map it. We overflew the island to the mainland, which we collected the island and the mainland, put our control on the mainland. And so we're able to give them really good data for the island. They were very happy with it. Example of a wooded site. It would take us weeks to topo this. And then our level of detail would probably be a 50-foot grid. If you look at the LiDAR data down at the right, it's pretty obvious to see that something existed there before. a man-made structure. And so we topo this site. We flew one mission out there, and we would turn out topo on this in a week or so. And whereas, conventional surveying would take forever. Just a little bit of comparison, LiDAR down below, imagery up above. You obviously see the vehicles have been removed. The power pole there has been removed, so you're left with the ground surface, but you can kind of see you're looking at the same area, and that the LiDAR process, and they remove any obstructions, anything that's not natural ground. Colorized point cloud, as I showed earlier, to me as a surveyor, not really that useful. I like topography. I like knowing where the ground surface is, but some people want to see that colorized point cloud. So you can see it's pretty incredible what you can do with imagery in a point cloud now. This is a great application of it. This is an old mine cuts. That doesn't look like much, but those rises, it can be from water level, can be 50 feet high. So surveying that would take months. And we are able to fly, 1,000 acres a day with a LiDAR UAV and get incredible topography. Just another use where safety would be a big issue. This is a jetty. We're now flying for the Army Corps of Engineers, which was a big hurdle. We like showing this picture because you can see the definition that the Regal box picks up with the rocks. You can see each individual rock. They were doing this for post-construction to make sure the contractor built this jetty right. And they didn't want anybody walking on those slippery rocks. So you can see that LiDAR really gave them a good look at this. I mean, they can pick out every rock in it.
Hey, David, we've got 3 minutes left. Just giving you a heads up.
How much?
3 minutes.
Yeah, I'm wrapping up. All right, so, and all that can be included together. So I'll go through this pretty quick, but topography, subsurface utilities, LiDAR data can all be fused together and pushed out. So, I mean, this is an example on that on a gas gate station. And I'll show you another example. This is a totally autonomous site. We had a USV, which is a remote control boat, mapping with multi-beam, and a UAV mapping LiDAR. And so you can see that the data is combined together. It's seamless, subaqueous to upland, no gap. You can see the water line traced there in magenta, I think. And so then it can be contoured. We didn't fly the imagery. So people have griped that the imagery stinks. We didn't fly that's free from Labins because the guy didn't want to pay for imagery. Just to show you how much data we can include quickly. This is the convention center. We mapped this in one day with our UAV, combined it with USV data from underwater, and then showed it the next day at a conference. So there was a conference at the convention center. So you can gather a lot of data quickly. Ortho image of the same convention data, done the same day, delivered the next day. And I always like to show this. I hope I'm not going to run too long, but I'm a science geek. So what's next? What's the future bringing? Well, SLAM technology where you don't need GPS and you can map tunnels with UAVs or buildings inside is coming. It's getting here pretty quick. So this is from the movie Prometheus. And this is what they're showing was the future, and the future is here. So I'll go ahead and play it. I hope you can see it because I know sometimes it doesn't come across, but you'll see them grab these round balls out of a bag and they're going to fly and map the tunnels. We've actually been looking at buying one of these systems that do inventories in warehouses. Obviously, they're not going to be round balls. They're going to be drones that fly with props. But that's basically going to map the tunnel in real time. If it comes to a dead end, it turns around and goes back. And it basically keeps mapping until the batteries run out and it returns to home. That exists right now. So I'd say the future is here when it comes to mapping. Now, we don't have the real-time 3D graphics that they had back at the ship, where they're looking at a hologram of the tunnel. So maybe that's the next thing to come. But real-time SLAM mapping is coming. It's pretty much here. So with that, you can see the hologram being built. That's the future.
Right,
so does anybody have any questions at this time?
All right, we actually don't have time for questions at this point, but you are welcome to put your contact info up into the chat, and people can reach out to you directly.